14, we need to know how to convert temperature. So the centigrade is going to be the Fahrenheit minus 32 in parentheses, okay, times 5/9. Like I said, like 5/9. Okay, the Fahrenheit would be the 9/5 the centigrade, and then add 32. And the Kelvin is your centigrade plus 273. Okay, so those are the formulas you should use. And just look at the problem, see what it asks you, and convert it. Should not be that difficult. Okay, we now go into, we went into the expansion of something. So there will not be a linear expansion. I just did a volume expansion. So your thermal expansion.
Are we going to have one of those problems with the ball and you have to fit it through the hoop?
Nope.
Dang it, I like those.
Yeah, but that takes too long. So I just did a real simple problem. The change in volume is going to be equal to the original volume times the beta times the change in temperature. So you should be able to do the, tell me how much the volume is going to change by just taking the original volume times the beta times the change in temperature, yeah?
Okay, and then the beta equals the alpha thing.
Well, we don't need to know that, the beta will be given.
Oh, okay, sweet.
Yeah, I can't give every question, it's just a midterm, so we just use point blank straight equations. Okay, then we start going into the gas laws. Okay, so know your gas laws. One of the gas laws are going to be on there. I'll put it up here. Each one up there you need to know, but you're only going to have 3 of them. I mean, one of the 3, but it might be P1 V1 equals P2 V2. That would be a Boyle's law problem. So if you see pressure and volume changing, that will be it. You might have this one, V1 over T1 equals V2 over T2. That's Charles' law. Just be careful when you use a temperature, it has to be converted to Kelvin. So use Kelvin. A lot of you guys make minor errors when you do not use Kelvin for the temperature. And the final law that's in this group is P1 over T1 equals P2 over T2. And once again, this has to be Kelvin. This is Gay-Lussac's law. So you need to be able to recognize the problem. So you say, okay, if it doesn't give you pressure, use Charles' law. If it doesn't give you volume, use that law. Okay? Another equation you're going to have to do is a separate problem. Make sure you know the ideal gas law, PV equals nRT. Okay? So you look at the problem. You should be able to calculate what it is. Okay? The value R is what? 0.0821. Okay, so then you should be able to plug it in the formula and calculate any of the parameters that are going to be missing to doing that. Okay, now, in this chapter, the last thing we talked about real gases. You need to know the 2 things that make a real gas a real gas. What are the 2 things that make a real gas a real gas? Real gases, what do they have? Number 1, what's that? What do they do?
They expand.
No, all ideal gases expand too.
They have intermolecular.
There we go. So number 1, they have intermolecular forces. And number 2, what also do they do?
Oh, they have volume.
That's correct.
What I
They
was
take
trying
up volume. Take up space in a real. They call it the molecular volume. Okay, so they, a real gas is just a dot in an ideal gas is just a dot in space, like a point is in geometry. Doesn't take up any space. But in a real actuality, an atom has volume, and so when you start compressing it, that volume is gonna make a difference in your equation. Okay, so now we've got to our chapter on, we finished, this is chapter 14, yeah?
Yeah.
That's done.